Yes. Thank you all for coming here. So we are on to the next session, the last one before lunch. We have Niranjan here with us, and he'll be talking about movie successes and the prediction of it. So let's get right to it.
Thank you so much. Hi all, thank you so much for being here. When so many other sessions are happening, I'm really honored that so many people have turned up here to spend your time with me for the next 40 minutes. I really hope I do not disappoint you. So how many of you here are interested in watching movies? I mean, yeah, almost everyone, right? So I'm a movie fan, just like every one of you, and I always wondered why certain movies work and why certain movies do not. And I've constantly been thinking about it for the longest period of time. And then when I started my undergrad program in data science, I thought I can marry my interest with what I'm learning hands-on there. And it started as a personal fun project, but then I never thought the results would be good enough to be able to speak in front of all of you. So if you don't mind, like, if you scan the QR code, it will take you to a Google Forms, and you can just type in any upcoming movies that you are interested to know about. And then towards the end of the session, we could download the trailer and see what my model says about the success of that specific movie. Let's just take a couple of minutes before we move on. All right, thank you so much. So this is what we're going to be talking about today. To start with, the motivation. Like I said, a movie's success depends on so many factors, often complex, because it involves people's reception, market boundaries, languages, the time it was released, and so many other factors. Especially if we observe that there was a dip during COVID, and then the movie industry kind of restarted after that. So this is the number of hit movies, so to speak, that spans over this time, and we are seeing. I mean, so many movies are being released every month, every week, but if we look at the graph, the number of hit movies before COVID and after COVID, it's a huge slump, right? So this is one of the motivating factors for me to spend this time and analyze like what's going on here, and if there's a way to sort of understand what the trailers, what the posters, and what other metadata can we make sense about. So I started gathering data from an open source movie database called TMDB. It's the movie database. It's IMDb minus all the charges that you have to pay them, and it has contributors, right? So all of us can contribute to specific data type of the entire data set. So I used TMDB's APIs and the master data set to get a like what I would like to call as raw data, and then I sort of put a filter on the release year because YouTube came around 2007 2008. So it's fair to expect that in the next 2 to 3 years, YouTube had more prominence. But also, the MPA in the US came with regulations of how the trailers should be made in 2012. So that's a fair enough guess to know that people started watching trailers on YouTube at that point in time. And then the other, with the data that I had in hand, I went to YouTube to fetch the videos and then download them at a standard MP4 format, and then use that for my data processing. And then I adjusted the budget and revenue for the purchasing power parity because TMDB had all of the data in US dollars. Outside the US, a lot of other countries use their own currencies, and usually the market rate is not the right indicator of the value of the local value of that currency, so to speak. So in layman's terms, it accounts for the cost of living, it accounts for the cost of inflation, it accounts for the taxes and all of that, and kind of lays out a level playing field for all the currencies because the data is from around the world. And then what I was specifically interested was the budget to revenue ratio. So I put in X dollars into a movie project today. What X of that am I going to get back after the movie is run? So I'm using that parameter to sort of determine if a movie is a hit or a flop or it was just breaking even. So we'll get into that in the next few slides. And then, like I said, I gave 5 levels of it, and then that was scaled down 1 to 5. So the budget to revenue ratio is a key factor for the entire project that I did. And so the first scale is considered flop, that I put in $1, but I only got back 50 cents. So that's the first level, and then the second level is called the below average level, where it's just breaking even sorts. And then the third one is average. I got my money back, but not too exciting. It's just 50% more than what I invested in. And the fourth one is the above average scale, where it's 1.5 to 2.5x. And scale 5 is blockbuster, where the ratio is 2.5x. Usually, a handful of movies reach this blockbuster scale, and the people who are bankrolling a project, a movie project, are very interested to at least achieve 3x of what they invested in. But only a handful of people are able to do that. So getting into what the data looks like, so there's a clear correlation between how much money is being put in and how much money is being taken back. But so not everyone can put in so much money to get that much return. So the idea is to sort of help people somewhere over here to see if what they are trying to present in the trailers get conveyed properly to the intended audience, and is there a way for them to sort of improve and then achieve that 3x or 1.5 or 2x factor? So, and mostly, so the data also had a lot of things about the genre, and then people are interested in drama, comedy, and action. Yeah, like there is not enough drama in life, so. And then, so I analyzed the brightness in a trailer, the saturation, the color saturation in the trailer, the sound that is used in the trailer, and then the kind of music that's used in the trailer. I wanted to see how that ranks with the just the people's perceptions. So, and this was kind of interesting because people are interested when the trailer is saturated a bit, at least, and then they want something that is not too bright, and that's kind of saturated enough. From what I see on OTT platforms, most of the series that are shot these days kind of follow this trend. The colors are a bit saturated. If something is shot in New York City, it appears a lot more. The contrast is a bit high compared to what we actually see, and there's also the padding on the screens to enhance that view. And the sound has an interesting, an interesting impact on the trailers. So if we look at the bottom right image, the spectral centroid, it's the center of mass of the sound frequencies. It's to do with how sharp the sound is coming out. So even before getting into the stories and even before getting into what the movie has to offer, these things are actually captivating people. So it's really important, it's marketing, right? So it's really important for anyone to sort of make it more attractive and get more people into watching the movies. I think I just spoke about this. So from each of the videos, I extracted these features. So the data we're talking about is about, so I had about 3,800 videos, and then from each of these videos, I extracted these scores. I calculated the average of that videos, and then I put it back to the, I added that back to the TMDB's database, because that's what I'm using to run my classification model. And then, again, this is fed into the first layer of the CNN. So this is the architecture. So the input has basically 8 features. So it's the things that to do with sounds, and then we have genre, the revenue, the budget. So everything is fed as the input layer, and then from each of the hidden layers, I'm kind of dropping out on so that it's a regularization technique, so that it doesn't end up overfitting the data. So yeah, and then I'm using softmax to I'm using it at the output layer, and then the output is classified, but it's basically the probability for one of the 5 classes. This is what the network looks like. Um, and when we talk about the measure, like the measure the measures were like pretty satisfactory, good. Um, with increasing epochs, it like the accuracy started going up, and then I also had to like uh, take into account the model loss into it as well. So this model looks pretty okay to me, but anyway, I would like to hear from you in the feedback section. Um, and yeah, so let's. I've been talking about what I did, and it's I think probably boring with this theory and stuff. Like, why don't we take a look at the response to the questions, and then we can try to see a few trailers, and we can see how that actually works. And if it's an old movie, that probably it's a good way to see if the benchmark is right. So I'm gonna have to like exit the presentation and go back to the Google Forms. So we have Wicked to be received so many responses, so we could actually see. It's going to ask for the budget, so just keep that ready information. So the predicted outcome is above average. Let me go and check. I don't know if the movie released or not, but okay, it's not released yet. But it says that it's going to be above average. So. So it should do 1.5 to 2.5x. That means it should be doing more than $300 million. So we'll wait to see if that's how good my model is. Let me go back to the other response. Okay. Gladiator 2. A lot of things I have not made really well because like the same programming, if the code works, just don't change it. So it's working and I'm not changing it. So this is also going to be above average, so it should do $500 million at least. So we'll wait and see. That's the hard test for me to actually know if it works or not. Theoretically, it sounds good, but I'm actually curious to see how things are coming out. Any questions or any feedback? So it's until 2024 July. Yes.
So did you check already
Yes. So I did check even before. Like there is this Indian movie called R, which everyone's talking about. But according to this, it is an average movie because it just took 2x of what they invested in. So they invested 550 billion rupees and they only got back 1200 billion rupees. So.
And the numbers match that.
Oh yeah, it did. I mean, it did. So and there are a couple of outliers in what I was doing the validation with, but the big ones are at least accurate. Yeah.
How does it handle different like region trailers, like whether it's like a Hollywood, Bollywood, or like Korean cinema? Like how does it handle those like trailers?
So I was reading about why people go to watch movies. Or what attracts one to keep engaged in watching a video. So the sound, the music, the background score that works. So if you take across any movie, like take an Indian movie or a Korean movie or a Hollywood movie, the instruments may differ, the genre of the music may differ, but what we are looking at is how loud that music is, and that seems pretty much in the same zone for all the, like even though it's different, like probably a Hollywood movie would have a bass at like some decibels, but and then the Indian movie would have some sitar or something else in the same decibel, but what is being conveyed over there is what I'm having to, like I'm asking you to come and watch my movie for 3 hours, so I'm doing all that I can to attract you, and that seems pretty much standard across whichever genre movies that we see, whichever language or region we take. Adding to that, which also happens to be my further research on this, is that the central, if you take the average of any if you take average of all the trailers, and then you find the standard deviation between 1 to 1.5 standard deviation from the mean, right? That's where the core message is often conveyed. That I watched around 40, 50 trailers from different, I mean, I've seen more, but specific to this project, from different regions, and it did have that effect. Like, there's a slow start, and then there is a rushed part towards the center, and then there's a peak towards the end. So that part is what in future I'm planning to analyze that core part. I think that will be more that will give you more data, make the network even more operating on more parameters.
I just had a question about your visuals, those 4 different graphs that you have shown. So is this is a scatter plot, or is
Yeah.
it something? But then I don't see like correlation, like a positive correlation or anything, right? So
Yeah,
how
so
do you interpret that?
so I'm just interpreting it as like where so people are voting on like 0 to 10 scale for the movies. So I was interested to see where the 10 cluster is, which part of the RMS is basically where. So if the RMS, the root mean square of a soundtrack is high, it means that the music is louder in that area. So often if you watched in trailers, like they'll play ding 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 music to sort of invoke the feeling of, oh my god, what's going to happen next.
Right.
So that kind of trailers have received positive votes from people. So it's just to see the data, nothing to there could be no correlation, but I was more interested to look at where people are in that spectrum. I could have used a different visualization, I get it, but I was not, like, I don't know if that answers your question, but even though if it's not linear, it could, a circular regression can fit this. So that could still be a good question.
I have 2 questions. So it's really cool analysis about the trailer. You also combine in like metadata about the movie, like the studio or the actors and that.
No, for this project, no, because it was taking a lot of time just to scrape the videos and just deal with it. So, but I have the data, so.
And then kind of related to that is like based on what you've seen, do you think there's like causality here, or are we mainly showing correlations? Like blockbusters have one type of trailer and smaller pictures don't. And then also like if a movie is unsalvageable, a studio might not put marketing dollars towards it.
Yeah.
So what do you think?
So it's more of a correlation that I'm trying to see. So this interest also comes from an Indian movie where there was 2 different versions of trailers released. So and they conveyed very different meaning. So that kind of sparked my interest. Okay, so the same scenes, if I jumble it, and in a different way, probably it'll appeal to a very different audience. Like I could market an action movie as a drama movie, or as well by picking up the scenes that I as a filmmaker do. So it's a very ambitious goal that I have. It's that I'll move everything to the cloud, and then it'll be an application where someone starting out with movies, they have like hundreds of thousands of trailers that's analyzed, and that has some data for them, and then they present their trailer into that tool, and then it's going to tell them that based on the trends, trailers like these have made only this much, or they have made much more than this.
Okay, so kind of more like modeling how
Yeah.
the correlation plays
Yeah.
out spatial.
Yeah.
I'm a novice, so I don't know. If this, but how does CNNs handle sound? I thought it was more for visuals.
Interesting question. So, recently I read a paper. The U.S. Navy, they recorded the whales, the blue whales sound, and then they sort of represented as a spectral image, if you want to say. So it is still possible to show sound in a visual way. And one of the easiest or the most seen or visible form is the audio equalizer in the media players that we use. So the floating bars, they dance according to the tunes. So that is a way we could handle that.
Okay. Cool.
So under the beginning of your presentation, I don't know if you covered this, but what was the distribution of movies from different languages in the theater?
So I didn't post it here, but I would say 60% from Hollywood, 25% from Asia, and then the rest from rest of the world.
For the budget, I was just wondering, did you include the advertising as well? Because usually for Hollywood at least, the advertising cost is separate from whatever the movie budget is for tax purposes. So I'm just wondering, like, if you did include that, because say for something like, I don't know, the latest Marvel movie, the advertising cost would be like 20 to 50 million, whereas an independent movie wouldn't even be, might be a couple of grand. So I was just wondering, like, if you included that.
So my bad, I was planning on to include a limitation slide, but the thing is I did not, because it's a crowdsourced data that I got, and when I'm having to pass through like several thousands, I could not deviate from what I wanted to do. But again, what I have in plan is that I'm planning to use one of the LLMs to pass the results from the internet, and it could be from some news article or someone's Facebook post that talks about how much a particular movie spent for their advertising. So that has to go in as a separate cost.
I say that because let's say your model has to go into production, someone's actually going to use it. It's most likely going to be the major studios that are going to use it. So you definitely would want to use the advertising cost.
This is Thanks for the suggestion. This is just the first maybe the half of the first step that I just But,
Were there any notable outliers that you remember? Things that did just both the two not correspond?
So it's about an Indian movie because that came top of my mind. So they invested about 400 million Indian rupees, and they got about 2 billion Indian rupees in return. So that is 5 times. But the model predicts it has 2.5 times. So that was a significant outlier because it just cuts half in that. So I think that would correlate with what he asked about including the marketing budget, because I think that would also have a push or pull towards pull from the people coming into the movie.
Any more questions? but you'll be around, right? So if something strikes up after the session is ended, you can always ask him. Thank you so much for joining us. Thank you so much for coming here, Niranjan, and we have fun. Thanks.